Welcome back to the Cave of Science, and today we're going to look at a couple of conversions, and this is between mole and the number of particles. The particles could be molecules or they could be atoms. And the conversion is 1 mole of any substance contains 6.022 times 10 to the 23rd particles. And again, that could be the number of molecules and also atoms. This is also referred to as Avogadro's number. So we're going to do a couple conversion problems here just to demonstrate this. So the first one says, how many molecules in 5 times 10 to the minus second moles of CO2? So let's start off. We're going to use our factor label method. And we have 5 times 10 to the minus second moles of CO2, carbon dioxide, and this will be our first factor. And we want to find out how many molecules. Well, we know in 1 mole, again we got moles on the top, moles will have to go on the bottom. 1 mole of CO2 contains 6.022 times 10 to the 23rd, and we're looking for molecules, so that'll be molecules of CO2. And if we look at what we have here, moles of CO2 is in the numerator, moles of CO2 in the denominator, so those two will factor out or cancel out. So we can go ahead and multiply the numerators by and divide by the denominators, which is pretty easy because these are all 1. And so our answer is going to end up to be 3.01 times 10 to 22nd molecules of CO2. Molecules of CO2 or carbon dioxide. So we do the math, and that's how many molecules we get. All right, so let's look at going the opposite way this time. And let me see if I can get a different color here. All right, so this time, let's go the opposite. We want to know how many moles of carbon monoxide in 4.6 times 10 to the 24th molecules of carbon monoxide. Again, carbon monoxide is a molecule. So let's start again with our known. So 4.6 times 10 to the 24th molecules of carbon monoxide. And again, I always like to put my first factor over 1. And we got molecules in the numerator, so molecules will have to go in the denominator, and our factor is, we know there are 6.022 times 10 to the 23rd molecules of carbon monoxide in 1 mole of carbon monoxide. So if we look here, our molecules of carbon monoxide in the numerator, it's canceled out or factors out molecules of carbon monoxide in the denominator. Go ahead and multiply the numerators divided by the denominators, and it will come out with an answer of Let me erase that there. Get that out of there. Okay. Go back to my pen. And that answer comes out to be 7 point. Oh, come on, hit it. There we go. 7.6 moles of carbon monoxide. So there's an example of going either way. Again, this is our factor. There's 1 mole will equal 6.022 times 10 to the 23rd particles, molecules, or it could be atoms if you had a single element there. All right, so till next time, this is the Cave of Science.